All right. So as mentioned, I'm from the University of Technology in Dresden. So we're quite old and quite big one from Germany. We've got 18 faculties and 121 disciplines for our students. Well, the rest is up here. Maybe got a little story to start. My first experience with EasyBuild, which was about 2 years ago. I was working in a project and we had some particular software we needed which had some dependencies with specific versions, and there were no modules on our system. So I ended up starting to write an easy config for these dependencies. And after a lot of reading documentation, checking how to build these dependencies, and finally stitching together this easy config, I ran EasyBuild on this easy config, and it failed and it deleted my easy config. This was my first experience with EasyBuild and my first bug report. Yeah, well, things have improved, and almost 2 years later, as Kenneth already said, I contributed a lot to EasyBuild, especially with regards to TensorFlow. Yeah, but I'll come to that. All right, I'm actually not directly from the TU, but from our Central Scientific Institution, which is called the Center for Information Services and High Performance Computing, or ZIH, just for short, which is the German abbreviation, so don't wonder. We are a member of the Gauss Alliance, maybe some here, might be two. And well, we basically do the communication infrastructure at our university and operating the central IT infrastructure and basically support the other departments. But we also develop our own software or do our own research. So some might have heard of Scorpy or Vampire for performance analysis and tracing of applications. We've got a quite big cluster named Taurus, which is in phase 2 now, which has about 47,000 processors. We had some ZendyBridge nodes, but they're gone. So we have 1,600 Haswell nodes now with varying amounts of RAM. And most of them have 128 gigabit local SSD. We have some bigger ones, but that's pretty much a default. So we have node local storage on all our nodes. We also have some GPU nodes, so some older ones with K20s, some newer ones with K80s, and yeah, just recently some Power 9 nodes with V100s. And this is where I came to TensorFlow because I wanted to use TensorFlow 2, and I better wanted to use it on our shiny new Power 9 nodes with the Volta GPUs. And instead of fiddling around with this TensorFlow installation procedure manually and forgetting afterwards what I was doing, I decided to write easy configs and then beat it till it works on Power 9 too. Yeah, it was successful, thanks to the work from the guys from Birmingham who did some work with Power 9 and EasyBuild. And yeah, we've got a couple nodes with consumer GPUs just for testing. But we also have some special islands, so some SMP nodes with a lot of RAM, like 2 terabytes. We've got some Xeon Phis there, Knight's Landing in this case, just some 32 nodes. And we've got the data analytics partition with 90 nodes and 2 petabytes of fast NVMe flash memory. And there's more coming, like 192 nodes with AMD processors. It's going to be hard for EasyBuild later, but let's see. And we've got 128 cores per node with a combined power of more than 750 teraflops. And then there's going to be the Superdome Flex called system with 196 cores in total and 48 terabytes of RAM in unified address space. So if an application really needs a lot of memory, that's going to be that. And even another 400 terabytes of NVMe memory. So if you need some fast data processing, that's going to be the system for it. So how come to EasyBuild? Well, we started with some Red Hat system in RHEL 6 and environment modules. And we basically had all our modules and software custom built and written the modules by hand. Yeah, well, it was difficult. And in 2016, we switched to LMOD because LMOD had some nice updates that made us suitable for our system, like the spider cache, which led to performance improvements. And especially the depends on directive or function with the reference counting, which was the tipping point to make us use it. We started with a separate EasyBuild environment. So we had this meta modules called modenv for EasyBuild and Classic, where the Classic environment contained all our old environment module stuff, and the EasyBuild, the new one. And we used LMOD as an opt-in, so it wasn't the default until 2017, where we basically only installed new software with EasyBuild, and just some software that was particularly difficult, which went to the Classic mod environment. And just about 1.5 years ago, we had a big update for the supercomputing system 5 with a RHEL 7 system. And we started completely fresh. So a new modenv was introduced, a third one now, called SCS5. And there are only EasyBuild modules there, and this has become the default. And the old ones are basically deprecated, so users should no longer use it. We've got about 1,300 modules times architecture, so there are more than that in total, but just to give a rough number. And we use, for historical reasons, a flat module structure, so nothing hierarchical there, because, well, users tend to just load their stuff and don't want to fiddle with load the compiler, load this, load this. So that's it for now. We have some custom easy configs, but no custom easy blocks, because easy blocks were too difficult to write compared to easy configs. Easy configs are just easy. We have some commercial software like SDyna or StarCCM Plus, which there was no easy block. I think there is now. But for some, we just install it manually because you have to download everything manually anyway because of registration stuff. So yeah, there is some manually installed stuff, but mostly it's EasyBuild. So now to our model environment. We have a heterogeneous cluster, so we had Westmere, Zendybridge, Haswell, Broadwell processors, and now the Power 9. But at this point where we decided what to do, we had a lot of different architectures. So how to do that? We decided on a shared module folder, so all the modules go, or the module files go into the same folder, but we have separate folders for the compiled stuff and headers, so where the software actually goes. And we have a symlink, which is quite short, which is then symlink to the appropriate subfolder depending on the architecture. We basically just did two, so Haswell and Zendy, and basically that were our maximum architecture we compiled for. This might change. So for example, for the AMD, we're gonna need another. The benefit is we can do a most optimized build because most of our processors are Haswell, but there were some Zendy, and the newer ones, well, almost Haswell. And with the symlink, it's pretty much transparent for the user. So he just does a model load, go to the compute node, if interactive or in a batch job, doesn't matter, and it just works. It doesn't have to fiddle with pass or loading later or have to take care on which partition they are on. So they basically don't know anything about this or don't have to. And it also helped for some regression checks for some it's hardware dependent bugs. So if something happens on only one architecture but not on the others, having two different trees helped us in fixing or finding those bugs. But symlinks are not a good idea. Especially Basel can't handle symlinks properly when building software. So that was one of the problems we had with the symlinks. So the better idea is to use bind mounts. So it's basically transparent for every software and it just looks like this is an existing path. So if anyone wants to try this, use bind mounts. Saves a lot of trouble. And now we have another mixture again, because we have the mod-n for SCS5, which uses those symlinks above. But we also have another environment called ML for machine learning for the Power 9 nodes. Because initially we intended to not install all software on both architectures. So the machine learning guides usually don't need the same software as the ones using the normal CPUs. So just to save us some work and space, we use different mod environments to distinguish between those. So for the user experience on our nodes or on our cluster, we use Slurm as a scheduler. We have one architecture per partition. So if the user runs a job, it always runs on Haswell only, Broadwell only, Sandy only. We use Lustre for our file system. We've got different kinds of storage, so from local SSD to distributed SSD and even to tape. We now use workspaces that expire after a given period to make users not trash Lustre, because Lustre performance goes down with a lot of files and users just keep dumping their stuff into our scratch partition and Lustre keeps getting slower. So now they're workspaces, so if they don't save the data, it's gone after a given period. And we also use some NFS and even Lustre over NFS, but yeah, reasons. And as mentioned, we use lmod. We also have an extensive wiki where we help our users how to use Slurm or how to use a certain piece of software. And there's also an automatically updated list of installed modules per mod environment. And finally, we use a ticket system where users can tell us if something's not working or if they want a specific software installed or just some general help. As mentioned, as ZIH, we support other departments, so they're all, so here I want to do this, how do I do that? That kind of super tickets come in. And our software support team for installing modules and stuff was only one person for a long time, with some exceptions for software like Vampire, which is due to licensing a little bit different to install. But yeah, it was one person maintaining the software stack and creating module files and stuff, probably caused by how difficult it was to not get into each other's area when installing some stuff. Now we have 2 or 3 people, depending, who support that and just use EasyBuild. It really is much easier, and yeah, we mostly rely on the official easy configs. We have some custom ones with minor changes, like for OpenAPI example, or where we use a different version of something. There are some user-provided easy configs, just as Kenneth already said. So some users do write easy configs and send them to us, and then they're gonna be installed. As mentioned, we haven't written any easy blocks so far, so we got to be fine with the ones there are. And some software still installed. Yeah. We do have an extension for EasyBuild, which is in form of a wrapper script, which basically is particular for our Symlink setup there. So in the start from our wrapper script, they determine the architecture and set up where the installed software goes, and load the EasyBuild module and site-wide settings and everything. So it's pretty straightforward after that. And most importantly, it sets group write permissions and the EasyBuild command group or option group writable installed here. So as mentioned, there's a team of 2 or 3 people installing software, and they are all part of this group, which has access to this folders, and so this is mandatory, so they can all work together. There's a separate script which copies the module file to the user visible location once it has been installed on every architecture, and it also checks that the software is actually available on every architecture. But it's pretty straightforward and nothing big. We also have some hooks for EasyBuild, for example, to set the CMake prefix path. A lot of our users use CMake. We've got guys from the Helmholtz Center in Dresden, which for their Pick on GPU simulation software, for example, use CMake. And for them, it really helps that our software sets the CMake prefix path. There's an open pull request now, so this might be the default for EasyBuild in the near future, I hope. Currently, we use a shared folder as a repository where the installed custom easy configs go, but we plan to migrate to a Git repository, but that's not done yet. So in conclusion, EasyBuild greatly simplified our software installation. Thanks for that. The community easy configs, of course, save a lot of time. Mostly, you just download the new version, install, and done. But the toolchain concept of EasyBuild makes it sometimes a little bit harder than it should be. So, for example, when there's a major toolchain update, like twice a year, there are a lot of easy configs that need to be created, checked, tweaked. Yeah, that's a lot of work and could be better. There is this try option thing, but for dependencies, it doesn't really work that well. And we have a Trini project for that. He should develop a web app which should exactly help with this thing. So basically create easy configs for a new toolchain and handle the dependencies so that it's all consistent. Let's see how it turns out. It's heavily work in progress, so I don't even know what the current state is. Let's see what turns out. Might be of help for the general community. So yeah. As a midterm goal, we plan to go to the hierarchical model structure 2. We already use this in a DLR cluster that we also manage, and plan to do it on our own cluster too, and just teach users, because with the growing number of installed modules, it just becomes unwieldy to have the flat module naming scheme. Yeah, that's it. Thanks.
Hi, thank you. Probably unsurprisingly, I have a question about the symlinking, since we do that. What was the issue that you had with Basel? Because we have a system where we do the symlinking, where we have TensorFlow 1.15 installed with the EasyConfig from the public repo.
Yes, that is because you use the EasyConfig and EasyBlock with the patches from the public repo. So there are actually patches to TensorFlow in the EasyConfig, which allow the symlinking to work.
Okay, so there's no reason for us now to have to move.
Yeah, this was one example where the symlink issue hit us, because that's Basel, which partially resolves symlinks at some point, but not at another. And with a patch to TensorFlow, it works. Yeah. But
sounds like a very Basel thing to do, to be honest.
Yeah. Yeah, I think it's even the problem that GCC, when you invoke it with show me your built-in include path, that it reports the resolved path. And later on, when it's compiling, it uses the non-resolved path. And that's what Basel gets as an input, and nobody ever bothered using it on a symlink system. So yeah. I guess they don't care. I opened an issue with them, so maybe they can resolve it.
Okay, thanks.
I have a bit of a comment or not a question really, but this web app, the person who's doing that, it'd be interesting if we could connect to them a little bit, because I already did this pull request, which already like in the framework like interferes with the dependencies. So to be able to connect us, even if they had the part where they were just able to find all the updates like on the web, but then we could actually inject them in the framework. So rather than have it, I don't know how if they're doing it separately or within the EasyBuild already, but.
Yeah, I can tell the person to come back to you guys and probably join the Slack channel to discuss this. Might be helpful for both sides.
Just back to the symlink issue, I've done a lot of hand installs where at various points there's fully resolved paths. A lot, and it happens a lot. And so we just abandon symlinks at high levels for the same reason.
I've heard the warning before, but it surprises me because we have 600 packages installed, and I haven't heard anybody complain about something not working.
It happens quite often, and often it happens with Perl or Python modules installed and stuff. It just depends on what the particular user decides.
But do you notice it at compile time or at runtime?
At compile time.
Yep. An issue I had, which I remember, is, for example, when you configure something on one node and then you try to build it on another node and happen to come to another architecture, then you have this resolved path which don't match that ones that you're currently using. And yeah, for example, for CMake, this is an issue. So if you try to build something and try to continue building on another node because something failed and you just rerun and go to another architecture, then this resolved symlink becomes a problem. Yeah.
That's why all the people are using the mouthful. Yeah. There's no symlink, there's no path resolved.
Yeah, no, I understand that part, but I don't understand why we don't see the issues.
The reason you don't see an issue is that the path is there. So during installation, if something resolves the path and puts that as a path into the script or whatever, you don't see the problem because when you run, the actual resolved path will be correct.
Yeah. But I just heard it was a problem at compile time, so that doesn't match your story.
It's not a problem until you move something around and point that the top level symlink to something else.
It's more common for us at runtime, but compile time it pops up as well.
Okay.
But I think compile time is because it's resolving in compile time and things get fixed.
Yeah. So basically, we should, for every package we start installing, we should check this and then fix that as a patch to make sure it doesn't do that. Oh yeah. So we should fix that.
We are going to fix
RM-RFR.
Yeah, another issue I could imagine is especially with CMake in the build tree. So while you're building, before you install, you might have resolved absolute paths. And when you then go and run this from the build tree, you might not get your perfect architecture dependencies. So, and you don't even notice because, as you said, the path is there. So it's quite subtle. And you might never notice until you do.
So you mentioned there are 2 or 3 people working with EasyBuild. Are you the only one contributing stuff back? Are the others already, or are they planning to? Or just give everything to you and you take care of it? I don't know.
No, mostly they just use the existing easy configs and just tweak them. So there's nothing to contribute back to. And
the tweaking is site-specific stuff.
Yeah, to site-specific stuff. For example, they need this specific software version, but the EasyConfig decided, the EasyBuild repository decided to use another one. So it's something like this, or it. Oops. Yeah.
Don't ruin my talk.
Something which happened, for example, was a CUDA version which didn't work on our system. So they did tweak the tool chain to use the upgraded CUDA version so it works on our system.
Yeah.
So that's mostly what they do. In my case, I developed the TensorFlow 2 easy configs for installation on our site, but obviously it was relevant for others too, so I contributed them back. Because it was something I made new. The admins are just changing stuff.
Okay, any more questions? Okay, if not, we'll switch.